Okay, we're going to work on graphing inequalities in two variables, which means that we're going to be graphing them on a coordinate plane. Just like we solve systems of equations by graphing, eventually in the next section we'll get to solving systems of inequalities by graphing, and it will be the best method, unlike equations. Okay. So we start off with just this linear equation, and what we're going to do is this is the equation of a line, and this line is going to divide this coordinate system into three parts: the part that is above the line, the part that is the line, and the part that is below the line. And what we want it to do is we want it to show the parts that make this true, this inequality true. So the first thing we do is we forget about the fact that it's an inequality, and we graph this just like we would graph any linear equation. We start with the y-intercept. So we put the y-intercept at -1, and then the slope is +1, so we're going to rise 1 and run 1. We can do that again and again, or the other way, again, and so forth. And because this is less than or equal to, I'm going to make a solid line. If that were strictly less than, it would be a dashed line. So this is going to be a solid line, okay, like this. And then I have to figure out where to shade. So I know that for this inequality, part of the answer is going to be the line. Now I have to determine if the answer is going to be above the line or below the line. You know, which side is it going to be on? Is it going to be this side above the line, or is it going to be this side below the line? Okay. And the way I figure that out is if the origin isn't included, I plug in the origin. You know, the ordered pair 0, 0. So I plug in 0 for y and 0 for x. And when I simplify that, I get 0 is less than or equal to -1. That is not a true statement. 0 is not less than or equal to -1. And so I don't want to shade to include the origin. I want to shade the other way. Okay, I want to shade down here. So my answer is that line and everything below that line, like so. And that is the solution to that linear inequality. It's that. And that's all there is to it. So we move on to this example. And in this example, our line is y is greater than 2x minus 1. So again, I forget that this is an inequality, and I just graph the line. And so we graph it the way we've been graphing lines since chapter 2. The y-intercept is at -1. The slope is 2, so I'm going to rise 2 and run 1, rise 2 and run 1, or I could rise -2 and run -1. Now this line it's strictly greater than, so that means the line is not going to be included. Okay, the only solution is going to be either above the line or below the line, but it's not going to include the line. And the way we show that is that when we draw this in, we draw in a dotted or dashed or whatever you want to call it line. Okay, and then I do the same thing. I plug in 0 for y, and I plug in 0 for x, and I get, don't need that parenthesis, I get 0 is greater than -1, and that is true. 0 is greater than -1. So I want to shade the part of the graph that is including that origin, and that is above the line. So the answer to this one is strictly what's above the line, okay, which is all of that. The line is not included in that solution, just what's above the line. Okay? And there's more. Yay. Okay, so here our y-intercept is at -4. So 1, 2, 3, 4. And my slope is -2/3. So if I rise 2, I got to run -3. Or I could rise -2 and run +3. This will also be a dotted line or a dashed line or not a solid line, whatever you do. Okay, there it is, like that. And then I'm going to plug in 0. I get y is less than 0 minus 4. I don't either. I get 0 is less than 0 minus 4. 0 is less than -4. That's not true. So I'm not going to shade up here. I'm going to shade below so that I don't include the origin. And so it's just this little part down here. And again, we're not including the line. The dashed line, it's not a solid line. So it is not included. All right. Another one. Okay, here our intercept is 2. So we start at our y-intercept. Our slope is +3/4. So I'm going to rise +3 and I'm going to run +4. Or I could rise -3 and run -4. And this is a solid line. The line is included in part of the solution. And then again, if I plug in 0, I get 0 is greater than or equal to 0 plus 2, which is 2. That's not true. So I'm not going to shade down here to include the origin. I'm going to shade away from the origin, which is everywhere else. So that would be the answer to that one. And that is all I have for you for this lesson.